Hello, everyone. I'm Shelven from Phala Network, and today's talk is, I think, it's a part of the tutorial for the hackathon participant in our North America station. So, sure. And I think after this talk, actually, you can see the video on our GitHub, sorry, on our YouTube channel. So I think now we can begin. Okay, let me check. Great. So again, hello to everyone. I'm Dr. Shelven Zhou from Phala Network, and I'm the lead research. And today my topic is to introduce our fast contract, which is the Web3 infrastructure beyond the current smart contract. So this is my introduction. So actually, just feel free to follow my Twitter or just contact me on Telegram. You are also very welcome to join our Discord channel, and there is a developer dev channel there, and we are very glad to answer your questions there. And actually, I got my PhD degree in Fudan University in China, and I was major in software engineering. Okay. So today I think this is an introduction slide. So I will introduce many things like Phala Network, like for example, how the fact contracts look like and what it can do. So first, what is Phala Network? And I'll say the Phala Network is the underlying infrastructure for you to execute your contract. And it itself is going to be a Web3 computing cloud, which is compared with existing blockchain like the Ethereum. Actually, the Phala network will be more like, for example, traditional clouding service like Amazon, like AWS, or like Google. And but compared with this cloud service, the Phala network, because of its blockchain nature, is going to be decentralized, trustless, and price preserving because we use some special hardware. And now in our nets, I think there is over about 13,000 secure workers for you to use. So there is a lot of computing powers for you to use. And the Phala network itself is focused on the computing part. So to facilitate a full functional DApp, usually you need to store the data, right? So actually, we designed the Phala network to be with the capability to utilize the decentralized storage solutions. So with this service combined, actually, you can develop a full functional DApps which is able to serve millions of users. Okay, so this is a compare between the Web3 cloud and the Web2 cloud. I think the most significant difference is that the Web3 cloud, because of its blockchain nature, is decentralized and trustless. So, but compared with another blockchain, you can enjoy your privacy and enjoy the scalability of computing power in our cloud. So the secret to this advantage is that we utilize our workers, all the workers in our network is based on some special hardware called the secure enclave. And the secure enclave is a very important features in the, I think, in even about all the modern CPUs. So, for example, including Intel, including AMD, and even I think the chips from Apple themselves contain the secure enclave. So usually the secure enclave is it's a complete subsystem which is consists of several important parts. For example, first, your memory will be encrypted by special hardware. So it's usually contain a hardware-based memory encryption chip to encrypt your data in memory. And also, it's usually it's contains a special subset of the instruction in your CPUs. And these instructions actually can be directly utilized by the applications directly. So even if your operating system is malicious, For example, there is or it's compromised, for example, your application can still be safe because it's directly utilized the instruction provided by the CPU. So this isolates it from the operating system. So with these two hardware and the most important features that secure enclave promise there is two. The first is about the confidentiality. So this means your data it will not be leaked in memory because it's encrypted, and the data is can be only decrypted by the CPU itself during the execution, and after the execution, it will be encrypted again and write back to the memory. So this thing promises your confidentiality of your data and your program state. And another part is the execution integrity. So this means your code cannot be interfered. So even if the malicious attacker, even if they have the physical access to the machine, they cannot change your code, and they cannot interfere with the execution. So the execution integrity is also enforced by the hardware. So this means the correctness of the execution is promised. So you can trust that your programs can only provide the right results, but it will not be attacked and provide false results and provide unexpected results. So this is very important. So with this, actually, Phala has achieved some great advantage over existing blockchain, especially on the computing power scale, for example. And for example, on the Ethereum, since all the workers, they are based on the normal trivial hardware. So this means the execution result, the correctness of execution result cannot be promised. So to ensure that the result is correct, actually, the Ethereum require all the workers to execute your contract. So right, when you deploy a contract there, so all the workers will execute your contract, and to verify that they all provide the same result so they think they provide the correct result. And for the Ethereum, and so in Ethereum, no matter how many workers there are, and actually from the user point, there is only one worker to work for them because all the workers are doing duplicated executions. So this is why the performance and the gas fee on Ethereum is not that satisfiable. And on the Polkadot, they try to solve this problem by deploy, I would say, multiple Ethereum, right? So actually, each blockchain in Polkadot is considered a parachain. So and the Polkadot combine all these connect all these parachains together. So in this way, it can achieve about things it supports about tens of parachains. So this means it can achieve tens of the computing power compared with the Ethereum. But in our network, I would say each worker is based on the secure enclave. So each worker's the correctness of its execution is promised. So actually, in our network, a contract can be deployed to one workers or two workers or all the workers in the network is all okay. So this means actually if we deploy, for example, one contract on each workers or even multiple contracts on one workers, so this means our computing power can be linearly scalable to the numbers of our workers. And now we have 13,000 of workers. So this means 13,000 of Ethereum in one blockchain. Yeah, and next I will introduce our contract. So maybe you will use it in your hackathon. So our contract actually is based on ink. So when you do the programming, actually, it makes little difference between writing the parities ink contract and our fat contract. So the parities ink contract actually is based on Rust, but you need to add some special annotation to make it a contract. And your Rust code will be compiled finally to the WebAssembly. And the WebAssembly will be deployed to the blockchain for execution. So this is how the thing is going. So I think it's good to let's first see what's the ink contract look like, right? So this is the motivating, I think, example of the most typical example you will see if you try to write the ink contract. So this contract is a flipper contract, right? So this means there is a coin there, and it has two values. It can be true or false, and you can call the flip math function to change its value. So, and you can call the get function to read its value. So that's how it is. So for such a contract, the left part is the raw Rust code, and the right part is the ink contract code. So there is not many difference. So you can see the only difference is here. You can see there is many annotation for ink contract here to tell our contract engine that what each part is. For example, in this part, this means it give it a tag of the storage. So this means this is going to be your contract state, and it will be stored on chain. And this is also holds in Phala, because you can deploy the unmodified ink contract on Phala. But the good part is your contract state here in Polkadot, this state will be public on chain. So this means other people, even they do not invoke these functions, they can directly read the value from the blockchain. And but your contract state will be by default will be encrypted on Phala network. So others cannot pick at the value of flippers, and they have to read the value through the invocation of this function. Yes, and the next part is the constructor of the functions, and there is just the initiate functions for the contract to set the init states of your contract. So in this case, it provides two constructors. The one for so you can force the init value, and another it give you the default value. And the third part, this will be the real functions for people to use in your contract. And there is two functions. There is a little different. You can see the difference is there, the flip function, you can see there is a mute here. So this makes it a mutable function. This means in this function, you can change the value, you can change the state of your contract. So you can see here, it changes the value variable of your contract. And another, the get function, you can see it's just hold by default, it holds an immutable reference to the contract state. So this means it will only read the contract state, but it will not try to change it. So these are the difference between these two functions, mutable and immutable. While in fact, so since, as we say, we have these secure workers, right? There are secure off-chain workers, and it's very different from the other blockchain. So actually, that's why we improve ink contract, extend it, so it can be executed in our secure workers. So I think by trivia, you can think that fat contract means raw ink contract with some Phala provided extensions to provide some extra functionalities to your contract. Yeah, and this is mainly where your contract will be executed on Phala network. So you can see normally, for example, in the blockchain like Polkadot, your contract will be executed here by a substrate node, by the contract node. Oh, sorry, by the blockchain node. But in our case, your contract will be executed by the secure enclave here. And this is the off-chain part. It's not directly, it's not the chain itself. Instead, it's connected to the blockchain, use a bridge called the ferry. And this, I would say, this can enable some interesting applications. For example, first, your contract, this means your contract can still handle the on-chain transaction or extinct. So this means, when you use it this way, it's more like traditional smart contract on Ethereum. So users, they post some transactions with extinct on-chain, and this will be synced back to the contract for execution. And after execution, the contract will update the contract state and write it back to the blockchain. So this is how it works. But after we have moved the contract off-chain, so this enables another kind of request to handle. So we call this the off-chain query. So these requests, they should not change the contract state. They can read the contract state, but they cannot change the contract state. But they are sent directly to the secure enclave workers because they will export some port for you to invocation. So in this way they are more like servers on the traditional VPS, right? And in this way, users can directly send the off-chain query to the secure enclave to the contract in the secure enclave through our JS SDK, and they can get the result immediately without the latency from the blockchain. Yeah. So in this way, this means our contract is compared with the existing one. They can provide zero latency query result directly to the users, and they can utilize. For example, when you can choose to deploy a contract to all the workers in our blockchain, and this means all these workers, they can handle the request from the users in a concurrent way. So this means you can use all the computing power in our network. And third, it's about the privacy. I will say all the contract state is encrypted and stored on chain, and no matter you send the transaction or you send query directly to our contract, all the input to the contract is end-to-end encrypted. So all the privacy is promised. And the last part, since the contract is executed off-chain, this means you can send the HTTP request in our contract to read some data or invoke any existing HTTP APIs, which is provided, no matter provided by the Web2 service provider or the Web3 service provider. And I will show the example later. Yeah, and I'll say let's skip this part. This is some detailed explanation of what's the advantage of off-chain execution, the on-chain execution. So in short, I would say is that first it's enable the zero latency query of the contract, and second, after you move the contract off-chain, so this means you can do something like network connection to it. So you can send network connection out, and also it's enabled to receive the network connection and process it. Yeah. And I think this can be some reference for you if you try to implement some interesting application in our hackathon. So, for example, since the data is encrypted, and this means you can implement a decentralized exchange with our contract. And since it has so many computing power, you can do some compute-intensive job like rendering for the NFT artist, like train AI model. And since it has a very low latency, so it's a perfect choice if you try to implement it as a metaverse backend, as a game server end, or even just normal website backend. And the last, since it has the ability to access internet, it will be very easy to implement your own oracles with our contract. It just takes tens of lines of code. You can because you directly read the data from some, for example, HTTP service. And also, or even better, is that you can also send the HTTP request to do something. For example, to control your Telegram or Discord bots to send some message to our users. So all these things can be done with just one contract. Yeah, so this is some interesting application which has implemented by our previous hackathon. For example, someone can implement a secret markdown editor with our contract, and also it's you can do the control access on it. So only the authenticate users have the ability to read your document. And also there is a pass manager. And this is a Telegram bot, which is backed by our contract. So all these things can be done. And recently, there is also someone has implemented a two-factor authenticate tools with our contract. So all these things can be done. Okay, so I have speak a lot. So now let's do some demo here. And let's first see what we can do. And I have already deployed the contract to our testnet, and now let's run the front end for it. Okay, I run the front end here just locally, and this example called the redeem Pope example. And before we really go to the contract itself, we can see to connect to this contract. Actually, there are several parameters you need to specify. The first is the WebSocket endpoint. So if you are familiar with Polkadot, you will know actually this specify a blockchain node for you to connect, so you can read the data from the chain. But in our part, you will need to specify another URL here. So this URL directly connects you to our secure workers. So you just use it as a normal server. And this is the contract ID. And let's see. You can always query the contract states on chain here. And let's see. Here you can see some metadata about this contract. You can see deployer, the code it's used, and the workers, the clusters it is deployed to, and its initial instantiate data is used to init this contract. And now let's load it. Okay. So after this contract is loaded, and the first thing it will ask you to do is to sign a certificate. And this certificate will be used to encrypt all your following traffic to this contract. Let's do that. Yeah. Okay, so now we can see the real contract here. So let's first try to understand what this can do, And actually, this contract asks you to connect your on-chain account, for example, like your Polkadot or Phala account, to a GitHub account. So after you have done that, after you have proved that you really own a GitHub account, we are very glad to give you some redeem code, so to get some POP. So since this is a demo contract, there is no real redeem code. So the first thing we need to do is that let's set some demo codes here so we can get the rewards. Oh, let's check the number. 7, we are good. And to set this code, since this code will be stored on-chain, so you still need to send a transaction to do that. So you will see this is slow. Okay, so our redeem code is posted on-chain. Okay, so now let's see. First, this contract generates some contents for you to, this content should be unique because this contains the magic number, right? So it asks you to post it with your GitHub account. So let's copy this and let's go to my Discord account, and I will just post the contents here. And I will need to make these things public so our contract can verify it. Okay, so I have published the contents, and let's get the link. And after I have passed the link here and click verify, so our contract will send the HTTP request directly to GitHub to verify that you really posted the expect contents. So it will know that you really own this. You can see here, you really own this account. Yes, you can see the verified process is very fast because it's this is how the query works, right? It's very fast. And after it has verified that, it asks you to send a transaction again to redeem your code. So this this go back to the slow part again. So we can see the difference between the query and the on-chain transaction here. Oh, so finally yes, so I can get my redeem code here. Okay, so this is how it works. Yeah, so this is the underlying infrastructure. So after you have filed, you have requested the contract to verify your GitHub account. It will verify it with the HTTP request, and after that, actually you can do something more interesting. For example, you can ask our contract to sign a report for you, and this report will be signed by our contract with its secret key, so nobody else can provide the false report. And you can always show this report to other people to tell them you really own this account, and other people can also always verify this by get access to our blockchain and use the contract public key there to verify your report. So this is why we say in this way we can use the fact contract as the root of trust, because actually its contract is registered on-chain and it provides a report for others to verify. And if you are interested, you can always join our fact contract workshop to get the code and the tutorial there to see how you can deploy your own contract. Yeah, and with the HTTP request, there is many interesting things to do. And the first I will say here is very easy to use our HTTP request here. You can just use it with 2 function call and you are fine. You can directly get the result. And it can be used to read some data from the website, like token price, like the tweets contents which someone has published with like the GitHub repo, or like any other files from a storage solution like AWS and R-Wave. And also you can do something with it, like send some email, send a tweet, and you can let your Telegram bot send something, and also any other service with the HTTP APIs. Yes, and although in the query part, you cannot change your state on-chain. You can only read it, right? But we also try to provide you some cache, some local cache. This cache will not be shared on-chain, but it can be only accessed in the workers locally. And they can be lost if for example, you redeploy your contract. But it can also enable many simple and stateful situation and the logic to implementation. And it's just like a normal key value storage here. You can set the key value here, read it, and remove it. It's very easy to use. Okay, and the last part, I will say things, no matter how powerful the contract will be, and since it will be compiled since you need to rewrite it from scratch, and you need to compile to the Wasm, it still has the limitation. So I think it will be a very good idea if that you can, for example, use the contract to invoke any other existing program, even there are for example, x64 programs, and you just pack this program in a Docker image, and that will be very good if you can just use the contract to operate this image. So this is what we try to do in the future. And we will try to enable you to use your contract to run a Docker image and interact with it. So, and I think a very interesting use case is that we can use our secure workers, so many computing power, to make it a real render service. And so this means we can run the existing open source renderer, like the open source ones called the Blender, and we can run it in a Docker image here, and we can use our contract to interact with it to do the rendering job. And to do this, actually, I will say first we will use our contract to turn the existing storage service into a trusted one. So that means when they upload some model files, these models can be very valuable because anyone can use the model to reproduce your NFT image. So the first thing we do is that we generate a key in our contract. and this key will never leave the secure workers. And we use this to encrypt the model files for them, and then we can upload these encrypted files to the storage service. So your data is safe. And after that, after the user can send the request, our contract will download this file for them and decrypt it and send it to a rendering service to get the result. And after the rendering has finished, we will get the render result. Usually it's an image, and encrypt it again and upload it to the service. And finally, users can ask our contract to do the decryption for him to get the real result. So this is how it works. So let's see an example. So the code is available here, so you can see how we really done that. And what we do is that we first upload the file and get a file handler here, and we send it to our contract. So contract can do the downloading and the decryption and manage the rendering service itself. So let's see. So here, after we have sent the file, you can see this is the log of our workers. So has already done the rendering job here. Yes, and after this is done, the result image is sent to the users. They can download it, and let's see the result. Yeah, so this is what you can get. And hopefully we will enable the deploy of first we will enable a very limited Docker image, because Docker image can do a lot of things. And for example, we can only allow people to do the rendering in the Docker image. And then after we have evaluated the security of this, so we will, in one day, we will enable that people can upload any Docker image to our workers and use our service. Okay. So if you are interested, you are always welcome to go to our wiki to find the contents about our network and the contract. And also you can use our open source code repository. And also you can, I think from the wiki, you can just find the link to our Discord channel. Okay, thank you. So if you have any questions, you are very welcome to ask them to here. And whoa. So I see a question here. Inside private as off-chain workers instead of the parachain itself. Yes, this is correct. So the smart contract, your contract code will be uploaded to the blockchain. But after you have instantiated it, so the contract will be really executed by the enclave, and it's executed in off-chain workers. Oh, and actually about the second question here, actually you can choose to, so I think I will answer this, the question can be answered in twofold. First, your contract is not forced to be only executed by one workers. During the deployment, of course, you can choose to deploy it on multiple workers. And on the other hand, even there is one worker, we will say that your contract is safe because the contract state is still stored on-chain. So this means even if this workers, the only worker is die, since we got your contract code, we got your contract state, so you can always choose another worker to redeploy your contract, and it will restore to the previous state, which is encrypted and stored on-chain. And I would say from the security part, I would say Phala is exactly just like other contract platform, because both your contract code and your contract state is on-chain. So the only different part is that we enable the off-chain execution part. So for example, if you store some contract state in the cache I have mentioned, so this part, it can be lost. So if you just carefully design your contract and only store the most important parts of your data on chain, so your contract is still fine. Oh, there's another question here. Is it possible for a fat contract to accept instructions via a future XCM version? And sure, yeah. And this is exactly the direction we are forced. And I think we just soon, not very late, and we will enable the contract to read and send XCM in our contracts. So actually, you can always deploy a contract in in our network here, and you can have another contract, for example, like on the Ethereum and on the Moon River and on the Karura and on the other parachain, and we can communicate. For example, in the parachain, we can communicate through XCM, but on the actually, it's possible to communicate between Phala and the Ethereum because we have already built a solution called a subbridge there. But the problem is that the fee can be very expensive. But you can really send a message from the Ethereum to the Phala network and backward. Okay, so if there is no other question here, thank you guys for being here, and you can always see the replay on our YouTube channel. So, okay, so thank you guys. Have a nice day.